Welcome everyone. So today we're going to be working with Apache Beam and Google AI Studio using Google Colab. In order to follow the workshop, you need to have a Gmail account, okay? Because well, you're accessing Google Colab, so you probably already have a Gmail account. But we're going to be using Google AI Studio, and for that you need a Gmail. Okay, so the notebook is already linked in the chat and in the resources. I have also a solution notebook that I will share afterwards. It's here, okay, but I don't want to share the solution yet, okay? So we are here to learn, and solutions are poison for the learning process, okay? So when you look at them, they look easy, but coming up with the same solution yourself, it's a lot of work, and that's actually the learning process. So I will share it afterwards. So the goal today is to have some inputs from the users, maybe do some combination of these inputs, like for instance, combine it with some prompting, present this combination to Gemini, and which is a large language model from Google that is available in Google AI Studio, and then get the outputs, the predictions of this model, and well, present them to another part of the pipeline. We are going to be using BinML. We are going to be using the RunInference transform. And for the model side, we are going to be using AI Studio with an API key that you need to generate and use in the notebook. Don't worry, we are going to be doing this step by step. So just wait for a minute and you'll see all the details. In the notebook, I have already written some code. For instance, all the imports. It's just because I never remember exactly which imports I have to use. So that's already written some code, but we will try to write a lot of code also. Let's say the most important parts in order to, let's say, to learn how to use a BinML. So, okay, so without further ado, in order to have a little bit more of a screen size, I'm gonna put this here like this, okay? If you use the same notebook that I'm using, so you will see my code there, okay, because it's shared with everyone. So I recommend you to make a copy and to actually try to follow along, okay? If during the workshop you have any kind of issues, please use the chat. So I have it open here, so I should be I should be able to help you a little bit maybe if you put something in the chat. So let's start with AI Studio. Okay, so you have here a link in the notebook. So you open AI Studio. Maybe you are not familiar with AI Studio. So what is AI Studio? It's just Gemini and other models. See, here we have Gemini 1.0 Pro, Gemini 1.5 Pro, Gemini Flash. So Gemini and some other models available to create your applications using these models. The most simple use case is just, well, playing with the models as chat, okay? Like, hello, what's your name? So, and the model, well, it doesn't have a name, well, whatever. So we can also use this model programmatically, okay? So we have here, well, sorry about the survey. So we have here some button here that says get code, okay? And you can see, like, for instance, for Python, which is what we are using, there is already a little bit of code. So actually what we have been doing is copy pasting. We are gonna copy some code from these snippets that are shared by this Google AI Studio, and then we're gonna put them in the right place in our pipeline. But for that snippet of code to work with our pipeline, we need an API key. Okay, so click here and well, so I haven't saved change, I don't care, so just an example, and try to create an API key. As you can see, I have already created one here. If you are based in the European Union, the UK, or Switzerland, bad news. You need to enable billing in this project that gets created here in order to be able to use AI Studio. If you are everywhere else, and so anywhere else, then you will, well, you can use this for free. There are certain limits about the number of calls that you can make. I think it's 30 per hour or something like that, or per minute, but it's gonna be much more than what we need for this example. So wherever you are, just go here, create an API key. Okay, I'm not gonna create it, okay, because it's asking me to select a project, and I have already one, okay. And if you are wondering, it's like, but I don't have a Google Cloud project, so how come? So how can I use this? Don't worry about that, okay, because Google AI Studio will create under the hood a project for you automatically, and you will not be billed in that project. Okay, so if you're not in the European Union, the UK, or Switzerland, so you can issue this API key for free without having to enable any billing at all. Okay. So the details of the project are here, and the details of the API are here. If you click here, you will get the full API key. So I'm not gonna do that, okay, because I don't want you to use my API key, because it's actually, I'm based in Spain, the European Union, so I have to pay for this, okay, and this is my Gmail account, okay, so I'm paying for this from my pocket, but it's a few cents, it's actually not a lot, okay, but so when you click here, you can get the API key. So take note of the API key, and the next thing we're gonna be doing is we're gonna be putting that API key in a secret in Google Colab in order to be able to use it with our notebook, okay. So in Google Colab, you can see here on the left, this there's a symbol of a key. So if you click here, you can define here a secret. Okay, let me add a new secret. I don't know if you can read it. It's a little bit small. Okay, it's good if you cannot read it, because that's actually my API key. Okay, you put here something like, for instance, Gemini API key, which is what is in the notebook, and then you copy paste here whatever. Okay. So, and let me just remove this because I have already here this hidden. Don't worry about putting this in Colab. This is associated to your Gmail account. No one else will see the API key. You can try, and for instance, go to the secrets in this notebook, which is the same. The link that I shared with you is exactly this notebook, and you can see that there is no secret there. Okay, so you don't have my API key. So this is totally personal. It's not attached to the notebook, it's attached to your account. Okay, so you can share a notebook with the secret, and the secret will not be shared. So please go ahead, generate your API key, and copy paste it here. And remember that we're using Gemini API key as name. The name, you can change it later in the source code if you want. Okay, and that's all. So I'm gonna be running the first cell. I'm gonna connect here to the runtime. We don't need any kind of a special runtime. We don't need a GPU or anything, because our model is not running locally. Our model is gonna be running in AI Studio, and we're gonna be communicating with the model, sending some data, and returning and getting the answers from the model. Okay, so it's already connected, and I'm gonna run this cell. Okay, so this is already installed. You will see some error messages that you can perfectly ignore. So what we have installed here is Apache Beam with the interactive runner. So yesterday there were some questions, and not sure if it was in the session that I had or in another session. There were some questions about, can I have an interactive runner with Apache Beam where I see intermediate results without having to run the full pipeline? Yes, you can, and this is what we're gonna be using here today, okay? So I'm gonna hide the output of this cell, and I'm gonna move on. So here we're gonna be importing this interactive beam thing, and this is what is gonna allow us to see intermediate results without having to run the full pipeline. And we are actually, today, I don't think we're gonna be running the full pipeline. We're gonna be just having a look at each one of the P collections that we're gonna be creating to see that everything is going well, okay? Good. So let me run this cell here and then move on to this cell here. So we're going to be running a streaming pipeline, and we're going to be using the interactive runner. Okay. So these are the options that I'm using here with Apache Beam. Since I'm running only in code, and these are normally things that you pass as command line options. Well, I found this to be much easier to pass as like using this. Okay, so this lazy way of specifying the options. Good. We already have our pipeline options. Let's start with the machine learning side. So Gemini it's a large language model that can help you answer questions and solve tasks. Okay. The model has already encoded somehow some knowledge about the world. Okay, like for instance geography, which is what we are going to be seeing today here. Okay. So in order to have the model do the task that you want, you need to do some prompting. Okay, so you are probably familiar with this, no? All these prompt engineering things and all this. Okay, so this is the prompt that we're gonna be using here today. Okay, so let's try this first manually. So let me copy this. Okay, let me go here to Google AI Studio. Let's create a new prompt. Okay, let me copy paste here. Okay, no, well, I cannot make this bigger. Okay, but I'm just telling the model that it's, well, let me put here, so that is an expert in geography that knows all the capitals of the world. Okay, there are two ways of getting the model to do what you want. Okay, there are the way of trying to praise the model, so to flatter it and to make it work in the way that you want. You could also try to to threaten it. Sometimes it works, but normally in my experience, praising works better than threatening, just like with people. So we are pressing here the model a little bit, okay? And we are telling that whenever you have a country name, you reply with its capital. For instance, the capital of France is Paris. However, well, I don't know if you knew this, okay? So I like to tease my kids and my nephews with this kind of things. Switzerland has no capital. I don't know if there is anyone from Switzerland here in the call, but officially the Swiss constitution doesn't establish any city of the country as a capital because it's a federation and it's kind of a distributed federation. So officially it doesn't have a capital. For sure it has a place in the country where the government is, but that's actually not officially the capital. So we want our model to be as picky as I am and reply that when the country is Switzerland, it should reply with there is no officially recognized capital. Okay. For instance, if I remove this, let me remove this and I will copy paste. And I ask, what's the capital of Switzerland? Well, let's see what we get. Okay, so this is machine learning. We never know what we're gonna get as output. Okay, well, the model is wrong. Okay, well, the capital of Switzerland is Bern. Well, probably you would have answered the same. Okay, but we can make the model to answer something different. Okay, so now let me copy here the prompt. This, okay, where we are just telling the model that when the country is Switzerland, it should reply something different, okay? And I put here as country Switzerland. And if everything goes well, the model should only reply with the name, with the sentence that we have put, not everything in, okay? There is no officially recognized capital, okay? And then even if I now ask the same because the model has the context, well, see, okay, perfect. The model is doing what we want, okay? And if I put something like this, country Spain, it should say Madrid, okay? It's working as intended, okay? So this is what we're gonna be doing in our pipeline. We are gonna be presenting a list, a list of countries. We want the capitals of those countries, except in the case of Switzerland, that we want the model to reply this. Okay, so we are gonna have to combine the input of the user with this prompt, because if we don't put this prompt, the model will tell us that the capital of Switzerland is Bern. Okay, good. So this is the prompt that we're gonna be using. You can later play with this and use different prompts and whatever. Okay, so we don't have to use this. This is just an example. For the sake of this example, we're gonna make 5 calls to the model. So we're gonna present 5 countries only: Spain, Switzerland, Argentina, Japan, Colombia. Okay, so I have created this here in this cell. Okay, I have run this cell, and we have and now we have our input. Now, how do we make Bing to use Gemini without having to write a lot of code? Okay, so let me actually go here to the web page of Apache Beam, and there should be a banner here. So you see this Beam machine learning operations. Let me click here. So Beam has support for machine learning. It has always had the support for machine learning. It was used a lot, for instance, in the scope of ML ops. Okay, but here we're gonna be using for the different tasks. We're gonna be using BeamML for inference, for predictions. We are gonna present some input to the model, and we want the output. Okay. So for that we have this RunInference transform. Okay, and there are lots of examples here of how to use this. RunInference can work with local models using TensorFlow, using PyTorch, scikit-learn, many other formats that I don't remember right now. Okay, but let me actually share the link here in the chat if you want to have a look later on. It also works with remote models. For instance, an endpoint that you have deployed in Vertex AI, or any other kind of remote model if you happen to have snippet of code that knows how to communicate with the model, okay, which is our case here. Well, I didn't say this, I forgot. If you use TensorFlow, PyTorch with a local model, for instance, if you're using data flows, you can also use this with a GPU, and let's say the RunInference transform will make sure that you use the GPU. And the RunInference transform, it has other goodies. For instance, it makes sure that there's only one copy of the model loaded in memory at once, okay? Because, well, in a single worker, you don't need to have lots of copies of the same model because you can reuse that. So it makes an efficient use of memory and many other goodies that, let's say, just come out of the box available with RunInference, okay? But now, RunInference doesn't support all the situations yet, okay? So like, for instance, can I use Google AI Studio with RunInference? Yes, you can. You can actually use anything, as I said, but there is no a handler for a model in Google AI Studio, let's say by default yet. So we're gonna have to write our own. To write our own, we have to export from model handler here. Like we have to extend, sorry, extend from model handler. And this, let me go back to the one of the first cells. This is something that we have imported from BNML, right? Okay. And when we do that, so we need to override two methods. This method, I have already written that for you, and we will cover this step by step later, okay? But this one, well, we will need to write it. So we need to create a model, okay, and load it in this method. Okay? And RunInference will call this method whenever it needs, and it will make sure that there's only one copy in memory, and so on and so on. Okay, we don't care about how that's done. We only care about how to load the model. And I also put here as a constructor the API key because we're gonna need the API key here in the loading of the model for the model to work. Okay. To load the model, what can we do? Well, this is when we go to Google AI Studio and copy paste the code that was there, and we copy there and we paste it here. Let's see that. Before that, let me see if there's a question here. Do we have a rate limit to make inferences with the Beam pipeline to the Gemini API? Yes, we can. We do. Okay, so we are not implementing any rate limiting here in this example, but in the documentation of Apache Beam, there is a rate limiter for calling external, for calling functions in general. And in some of the examples that are linked in the BNML page, so you actually have the rate limiter that applied. It's actually rather easy. You just put the conditions for, let's say, the amount of calls that you want to make per minute, and RunInference will make sure with this rate limiter that you let's say that you will fulfill those conditions. So have a look at the notebooks and examples that are shared with BNML, okay, and there you will have some examples, okay, of the rate limiter. But that's actually one of the another goodie of RunInference, okay. So it solves all these situations. In particular, with this kind of APIs, and in this case specifically because we're using a free API key, we have a very constrained rate limits in the API. Okay, so very low rate limits in the API. So it's good to use a rate limiter. But because we're going to be using this with 5 examples only, I want to maintain the example as simple as possible. We are ignoring that for the moment. Check out the examples and all the details are there. Okay, good. Then let's go to Google AI Studio. So here we go to Google AI Studio, and well, there are lots of parameters that we can use with this model. We can even use different models. These Gemma models cannot be used remotely. They can be used in Google AI Studio, but not with the API. So we need to choose one of these three. Because I'm using my personal Visa card, and I'm paying from my pocket because I'm based in Spain, I'm going to use the Gemini 1.5 Flash because it's the cheapest of the three options. It's actually the one that has the lowest prediction latency. It's the fastest model. Okay, so I'm going to use this one. I encourage you to try any other model, like for instance, this one here, which is a larger model than Flash. the prediction is gonna take slightly more time, but it's gonna be almost immediate. You will see. And if you're using the free API key, so well, it shouldn't be a difference. So I'm gonna use this one, and you could also change some settings here, and this will be reflected in the code. Okay, I don't know. I don't want the output in JSON. I don't want this to be executing code, and the safety settings. Well, I can change them if I want. Okay, in our case, because we are talking about geography, I don't think this is gonna have any influence in the results. Okay. The temperature, well, we could put it higher, so for the model to be wilder, or this for the model to be more factual. Maybe, well, let's leave it at one, because our manual tests were done with one and it was working. I don't want to. Well, let's put it maybe 1.05. It's slightly different than one, so you can see that the code gets updated with this. Okay, and when we are happy with all these settings, we click here and get code. And well, so we have here all the code that we need. You see here are all the parameters that we have selected in the UI. So all the code that we need in order to use the model. Okay, so we are gonna be actually copying from here, import OS, import this. This package is already available in Google Colab, so we don't have to import anything. Gemini configure, okay, great. The configuration, the model, we're gonna be using Gemini 1 Flash, okay. And I'm gonna copy only until this point, okay, because the model is already created. The rest of the code that appears here is about how to use this model in a chat session, which might be super relevant, okay, but it's not what we need at this point, okay. So I have already copied this here, and I'm gonna paste this in this here as the body of the load model function. Let me actually paste here. Be careful with indentation. Okay, so this has to be inside the function. This has to be inside the function. This has to be inside the function. Let me actually select everything. This has to be inside the function. Okay, let me put some more space here. Let me maybe remove some space here. Let me remove the comments, okay? So people doesn't know that I actually have copy pasted the code from some place, okay? Let me remove this also. And then here, this is the model. Here we're gonna be, so let me actually have a look at the solution to see what I did here. What is the solution? Yes. We're gonna be actually just returning this. I didn't remember what was the API for RunInference, okay? So we're gonna be here returning the model, okay? Let me just put maybe a little bit more of here of indentation. So we return here the model, okay? Good. So this is the load model code. Does this have to be an LLM model? No, this could be anything. If you have a way to communicate to an external service that if you present one input to the service, it returns a prediction, so you can use that with RunInference too, okay? Because all that we are doing here is that we're using some model, which is an object that allows us to communicate with an external service, Gemini in this case. Okay, so basically what it makes is, well, so this makes an import. It's perfectly fine to leave these imports locally here in this method. This method is gonna be only called once per worker. It's not gonna be called a lot of times. Here, the API key, well, we need to actually change this because this is not gonna be in the environment. This is gonna be this variable that we're gonna pass when we construct the object later. The generation config, we don't have to do anything. And then here it's all good, okay? So how does the RunInference method works? Okay, well, so the RunInference method receives a set of predictions. No, sorry, a set of inputs, not predictions. Inputs, not predictions. Inputs. The model, which is created with the load model method. How does the model get passed to this method? We don't care about that, okay? We just have to know that whenever this method is called, this model is the same one that we have created in load model. And inference arguments that, well, we don't have any in this case, so we are not gonna use any here, okay? We could have maybe used this as inference arguments, but again, for the sake of simplicity, we are not gonna use any. And then for each one of the inputs, so we're gonna have here, because our inputs are gonna be strings, okay? Our inputs are gonna be these ones that you see up here, okay? So it's gonna be just strings, okay? It's not gonna be JSON, it's not gonna be nothing. It's gonna be just strings, okay? And the prompt, if you look at the prompt, so it was another string with a space here, we're gonna just combine the prompt with each one of the inputs, and then we're gonna call the method generate content for the model, and this will call the LLM. It will send all the prompt, and it will get the answer back. Okay, and this will be actually an object that has a lot of info. Okay, it has the prediction itself. It has, if there's any kind of error, information about the error, and if there are several answers, it will contain several answers as well. Okay, so here we will only have one, okay? So that's why from the candidates, we only get the first one, okay? And it will be only text, okay? But you could actually get more complex stuff. And for each one of these outputs as text, we will just yield, return each one of these. Because we are iterating over several inputs, we cannot use return here, so I use that yield, and the for loop will continue, okay? So the function doesn't end here, okay? That's why I'm using yield. There are many other ways of doing this also. You could accumulate in the list, return the list, many other things, but this is what I'm using here. Let me actually try to see if this, okay, this runs correctly. So it doesn't have any kind of syntax errors. So we can now continue with the pipeline. So far, we haven't done any bin other than creating the model handler, but we haven't written any kind of pipeline or transforms or anything, okay? So we are about to do that now, okay? And we are gonna start creating the pipeline. I'm gonna return my API key from the notebook doesn't have a secret access. Okay, I'm gonna grant access to this. Okay, good. So I have now this here. So in this variable, I have my API key, and now I'm gonna create here the rest of the pipeline. So for that, I'm gonna be using new cells. Okay, I could write everything in other cells, but I'm gonna use new cells. So I'm gonna run this first. What is in the countries variable? In the countries P collection. Okay, so well, it's kind of an easy question, right? Because it's a create with a static set of data. But in order to showcase the interactive runner, so let me show you how you can have a look at a P collection. If I put this here, I will just obtain, well, this is a P collection of something, okay? Nothing useful, right? So this is not really very useful information. I don't want to see this. I want to see the content of the P collection. Before we had the interactive runner in Bean some years ago, this was a problem because you couldn't have like visibility step by step about how your pipeline was behaving. Okay, but now you can do with the interactive runner, interactive Bean. You can say dot show, right? Here it is. Well, you can actually also like show the graph of the pipeline even. Let me see. Okay, it's a very simple pipeline so far, right? Because it has only one transform. Okay. And we can also have a look here, and instead of show graph, we can put here show countries, and then we will see the content of this variable. Okay. See, which is, well, the input that we have put, right? Okay. Question in the chat. When we make the API call to the model, the pipeline will wait until it gets a response? Yes. Each one of the calls that is made to the model, okay, here in this case, when we are calling this line, it will be blocking the pipeline. If you are running in a big runner, data flow, Flink, and so on, that will be parallelization, lots of threads running in parallel, etc. And then let's say the full pipeline will not be blocked, but each one of the threads will be waiting until it gets a response from the model and then proceed to move on. Okay, so if the model is super slow, the pipeline is going to be super slow. If the model has very restricted rate limiting thing, so well, so the pipeline can only move at that pace. Let's say if you have, I don't know, 30 calls per minute, and you set up the rate limiter to be 30 calls per minute, you will be moving at the pace of 30 elements per minute, okay? Because the calls are blocking. Yes, so the calls are just blocking. So this call here to the model, this is totally blocking. Okay. Okay, moving on. So we have here shown the countries. Okay, this is actually not a mystery. We already knew that this. Okay, but this we can apply to any P collection. Okay. So let's actually start writing the next step. So how do we do that? So here in the countries, so we have a P collection of strings, which is just what we need for our RunInference pipeline. And you can see here that the machine learning auto-completing is actually already writing code for me, okay? And then, well, so I call my model handler. Well, the model handler is a model handler is Gemini model handler, and actually, well, let me just put this here auto-completed, okay? Remember that the constructor had this parameter, one only parameter, which is the API key. I got the API key here from my secret because I previously stored my key in the secret store of Google Colab. I did that before the workshop. Okay, if you haven't done that yet, so do it, or this is not gonna work. Okay. Well, actually, this call should have failed if you don't have the API key here. Okay. And now let me call these predictions, okay, assign this to predictions, okay? So we have the countries, and then we pass this to the RunInference. And because we are using this model handler, this will be combined with the prompt, presented to the LLM, and so on. I run this, and look, it runs super fast. Why is that? Because it has not run now, okay? It's not running yet. So this is lazy evaluation, okay? So this is the specification of what's going to happen, but it has not run yet. When we run the pipeline, I could call .p.run, for instance, but then it will be useless because we will not see the output, okay? Or I could do this, the interactive runner, look, show me what it would run so far in these predictions, okay? Let's see what we get. And now it may take a while because we're, okay. Prompt is not defined, okay? Well, let me, it should be defined, okay? Let me run all the, I didn't run this cell. I didn't run this cell, okay, sorry, okay. Let me run this, okay? And let me run again this. I made this silly mistake. Well, now it's taking a while. It's going go to them. Okay, here it is. Okay, so the returns, the results are returned in the same order as the input. Okay, so we see Spain, Madrid, Switzerland. There is no officially recognized capital instead of Bern because it's using our prompt. Buenos Aires, Tokyo, and Bogota. See? Now we have made our first inference pipeline in streaming using Gemini and LLM, as easy as this, okay? Now you can play with whatever you want, okay? Like say for instance that I change this, okay? And I put I remove the prompt here, okay? And then, well, who knows what we are gonna get here, okay? Or maybe we could put something like this. What's the capital of, let me actually put here an F string, okay? What's the capital of this country, okay? Okay, and then I run this, okay? And then I run everything. So this is gonna be the same inputs, but now the prompts that we're gonna be presenting, they are different. And the model doesn't have any context. It's not gonna remember anything because we are not putting any memory. If you go to Google AI Studio, you could actually do prompts that have a chat, a memory, and so on. Okay, let me show you very quickly here. So if you go here, see, you can have history. You can have, see, a lot of things. So the model remembers the conversation. So, but we are not doing that. So, and because we are not doing that, if we run this now, let's see if we actually get the. And I don't even remember where I ran. Maybe let's see if this works. If not, I will run it again. See, now we get an entirely different output. Okay, so it says the capital of Switzerland is Bern, the capital of Argentina is Buenos Aires, and so on. Okay, good. Okay, and then if we recover here our prompt, okay, just prompt plus B again. We will get the same output as before. Good. What if I want to actually run the pipeline? Then, well, I can add another step here. For instance, I could do a predictions and bin map print, okay? Let's see, this should work, okay? Good. And then I could do a p.run, and maybe I will see some output here, the output of the model, because I'm calling again the LLM, okay? See, here's the output again, okay? So this is the same as, this is running the pipeline, okay? We have been using the interactive runner, and here we are just running the pipeline. Okay, folks, so this is all. Okay, so let's recap a little bit about what we have done. Okay, so you may be a little bit disappointed, like it cannot be this easy to use ML with Beam. It is. Okay, so this is actually the magic of RunInference. So what we have done is we have imported RunInference and we have used a custom model handler because we had some code that we know how to create a model. Okay, so this model just happens to be a model from Google AI Studio that has this Python code here after generating an API key and so on, and we can just use it like this. Okay, so after that, well, we just create a pipeline with some input. In this case, we are combining here with the prompt that we want, but it could be anything. And then when the model is presented with those inputs, it returns these predictions. Okay, and again, this works with anything. Local models using TensorFlow, PyTorch, scikit-learn. You can import Hugging Face pipelines remotely without having to load anything locally. You just put the reference to the Hugging Face pipeline and the worker will download it automatically. You can use remote models like the ones that we have seen here. There are handlers already for a lot of situations. For Google AI Studio, not just yet, okay, and they will be actually very soon included in the RunInference, and this workshop will have no, it will be even easier in that case because we will not even have to write the model handler even. Okay, so it's this easy. Okay, so if you look at how to make inference in streaming at large scale, so here we're running a very small example, but we could have done this at very large scale. There is really no standard right now out there in the community to do inference streaming pipelines. Especially if you're working in the cloud, it's one of the providers, Google, on other providers, and so they have the endpoints offering for putting models and being able to call them online, and you can do some streaming inference, maybe, I don't know, combining lambdas, cloud functions with that, and so on and so on. But again, you are attached to the platform of this provider. You need to have an endpoint, use a lambda, a cloud function. If you want to have an standard solution that is not attached to any platform, I think that right now Beam is the only solution that guarantees this. So I think there's a lot of potential that as new use cases for using streaming inference appear, so Beam will have even a more prominent role in this field. Okay. If you think of how many of these new websites that are appearing around AI work, like generating images and doing all kinds of wild stuff, a lot of them so have to run things asynchronously. So this is the perfect scenario to run something like with Apache Beam. So you just send your predictions and wait for the predictions to be ready. When they're ready in your output, in some kind of message queue, Kafka, whatever, so you load them in your web, in your app, and so on. So it is very easy to write the pipeline and very easy to integrate with any kind of existing platform, any web or any app.